This chapter introduces some interesting devices that are used to control levels in industrial procedures, and it could be liquids or it could be solids. This is a drawing of a complex industrial procedure, and the object of this drawing is simply to show how difficult it can be to control the level of a chemical. Notice there are pumps and valves and all kinds of devices. This drawing was supposed to show the most simple method of measuring levels. It's called a rod gauge, otherwise known as the dipstick. This drawing also shows a sight glass, which means that there are some procedures where you simply look inside to see what the level is. I'm told that in nuclear reactors, there are sight glasses where you can see inside the reactor, see what's happening with the fuel rods in the water. And that's something I don't think I want to do. In all practical measurements of level, there must be a boundary between two dissimilar liquids. In this case, it's a liquid and air, but it could be two different liquids with one floating on top of the other. Mechanical flows is still the most common way of measuring levels, but a mechanical fluid is also an invasive measurement system, which means that it's actually touching the liquid that's going to be measured. A displacement sensor works by measuring the density of a certain liquid. At first glance, it would seem that something is floating in the liquid, but it is not. The liquid is going to be squeezing on the sensor, and this gives you an indirect measurement of the liquid. In a bubble level detector, bubbles are introduced into a certain amount of liquid, and if the liquid is very high, then the liquid will oppose the amount of bubbles that are being introduced, and thus give you an indirect measurement of the level of the liquid. For solid materials, such as powders or gravel or plastic pellets, a paddle wheel detector is used. In this case, the solid material is going to cause the paddle wheel to spin, and then that'll give an indication how much material is in the tank. A conductive probe works only when the liquid reaches a certain level so as to cause the device to conduct. And so if you want to achieve different measurements at different levels, then you have to use more probes so that you get discrete measurements but not continuous. And we find that that's good enough for many procedures. Ultrasonic sensors are used when working with dangerous fluids that could be explosive because they are non-invasive and give a continuous measurement. The only problem is they could be susceptible to mist or fumes that form at the very surface of the liquid that's being measured. A capacitive sensor works because the liquid that's being measured is also considered dielectric, and if you have more liquid, then the dielectric is more and the capacitance goes up, and this gives an indication of the level. The capacitive sensor is invasive but indirect because you are really measuring capacitance. Then you have to do a circuit to convert that to indicate level. Here's a chart to help you select what type of sensor you need for measuring level. And of course, you have to decide, is the liquid explosive? Is it a solid? Is it a liquid? Does it form vapors, etc.?